Hey everyone, welcome to Rick's DIY. Hey, today I wanted to kind of go over some water heater maintenance for you guys. We just moved to a new house and finally getting around to kind of want to get a couple videos put up. And at our old place we had a tankless water heater, and I never really went over anything on that. I did a video of it being when I installed it, but I never did get it posted up because it wasn't complete. But here I got a Bradford White electric hot water heater, and as far as I know, nothing has been done to it. Who knows the last time any maintenance has been performed. So I just kind of want to go over a couple things on what you should do periodically, and maybe once a year or every 2 years. And so we'll start with that. So the first thing is we want to make sure that the power is off. As usual. So I just got my my handy Fluke volt stick again, and come in here, and I haven't shut the breaker off yet. It's kind of in this terrible crawl space. I mean, it's not terrible, but as far as getting to it, so should be able to see on the. Let me move that around. So on the video here, that it's lighting up when I'm near that. And so I'm going to go shut the breaker off, and we'll verify the power shut off, and then we'll proceed with the next few steps. Okay, so shut the breaker off. I'm going to verify that I'm not picking up anything with the volt stick, and the reason why I did that to begin with is I want to verify that this is working. So you want to make sure that it's working before you test it out, and then we'll go from there. So we can do the electrical side or the water side first. I'm going to start with the electrical side. So we have our incoming power here coming from the circuit breaker into the junction box at the top, and then from there the wires will go down through. And we got two of these. There's one at the top and one at the bottom. These have the set points in them, and the actual heating elements themselves are right here. So there's usually two of them on the larger water heaters, one on top and one at the bottom. And so so we'll start with that. So I'll grab a screwdriver. So you still want to be careful, even if you verified with just like that volt stick, or just shutting off your breaker to begin with and you don't have a volt stick to check. I'm going to pull this little junction box cover off. It's a single screw, 1/4 inch or a flat tip screwdriver in my case. The thing you got to know about water heaters in particular is they're higher amperage, anywhere from 20 to 50 amps on the electric ones. And with that, you got really high loads going on and off all the time. And what that does is that heats up the wire, and it expands, and when it cools down, it contracts. Expands, contracts, expands, contracts. So over time, the electrical will actually loosen up, and it's very important that you go through and tighten everything up. So just on this, but so you want to come in, and anyone that's installed this properly should have pre-tightened the wires in here. I'll pull this one off and we'll check and see if they actually did it correctly or not. And they didn't really, not the way I like to see it. So as you can see, I just pulled that off. So on these wires, you can see that they're not twisted together at all. They're just kind of there, and they put the wire nut around them, and they're using the compression of the wire nut to hold together. I personally don't like to do that. I'll see over time that loosens up. So what I'm going to do is I'm going to pull all this electrical off. I'm going to do one of them here. Okay, so I've got a little better picture here on that. And I got a couple of tools, electrical tools with me. Some strippers, cutters, and a pair of pliers. So Now, as far as the length of the wire when doing a pre-twist, this is good here. That's a little bit over 1/2 inch, maybe 5 inch. That's probably 1/2 inch. That's kind of limited, but see if I can do that without getting in the way. So what I'm going to do, I'm going to grab, and this is what you want to do anytime you have two solid or two or more solid connector or solid wires in a wire nut connection. The proper way to do it is not just to put them together and throw a wire nut on it. You want to pre-twist them. So in order to try to get the camera angle right here, try that. And sometimes it works better than. And then what I'm going to do, see if we can get these actually together and not. See that there, and just twist them with your pliers and try to get them to wrap around. It's not quite working the way I wanted it. Ideally, you want both the wires actually twist. It's not perfect by any means, but see if I can get a side angle there. It's pretty good though. It's pre-twisted together. Even if there's no wire nut on that, it's got a good connection. You want to do it where these start twisting together. You're down the line. At least get a couple revolutions. I'm going to twist this just a bit more here. And that's never going to come off. Even if that wire nut comes off, we just throw a piece of tape on there. Those aren't going to come apart. So we can throw that wire nut back on. Sometimes I like to look at them, make sure all the kind of the spring steel in them is good. And that one's kind of been separated. You won't be able to see it in the camera angle, but I got some more in the exact same wire nut, so I'm gonna put on another one. So I got that one done. I'm gonna do the other connections in here off video, but I'm gonna do the exact same thing to these. Button up this, and then I'll move on to the heating element section. So I just wanted to show you real quick. When I was doing this the black wire here, I just realized something, and that is that they didn't run a 4-wire or 3-wire plus ground Romex. This white case wire is called the Romex. What they did is they just ran standard 2 hots. So they're using this white one, which is generally your neutral. But because this water heater doesn't need to see any neutral, it's using that as a hot. Now generally what needs to be done is that needs to be labeled. A lot of guys will actually use a red marker or a black marker and mark this, or put a piece of tape on it. This is the proper way to do it. So I just kind of wanted to point that out. I got the black one here all twisted up, and it got a really good twist on that. And so there is no neutral. I just have the 2 hots in the ground coming in, and then there's some internal wiring. I had a wire, and I pulled this one off and looked at it, and that had to use the stranded wire. And when you have stranded wire, you don't pre-twist, so I just put it back in there. And so I got these good and tight. And then we'll move on to the next section. We'll get this tucked in, and then once you have this, like, you know, with this extra twist on it and everything, you don't need to run tape over your wire nut. I mean, you can if you really want to, but it shouldn't be loose at all, so it should never loosen up in that sense. But as far as looking this at it again, it's a good idea to always pull the cover off, you know, every couple of years, and just have a look at it, make sure nothing's chafing or wires heating up. That might lead to a catastrophic failure. But you know, everything looks real good. we got the top taken care of. We're going to go down to our next electrical section, and that's the top heating element here. Pull this cover off. Again, it's just a flathead or a 1/4-inch nut driver. Once again, electrical still off. And on the back of this will actually show the wiring diagram. We got our 2 hots coming in. Goes to that wire nut that was up top here, the blue one, and the yellow wire. So this is the top heating element, and then it shows how the wiring goes down to the bottom element and the lower thermostat. So there's an upper thermostat and a lower thermostat generally on these. So if I pull this up, you can kind of see here. So this is the thermostat itself, the setting. There's a reset button on here for a thermal overload, and so this is where you could adjust the temperature on it. And what you're going to want to do is I'm going to flip this up, and you can see this is the element itself. If you were to change the element out, this is where you'd come in with your giant socket. You have a special heating element socket generally you can pick up and do that. So the important thing is this is where you get a lot of that heating and cooling on this and on the thermostat and the expansion. So we're going to tighten these down. And on this one it's just a Phillips. So I'm going to go ahead and grab my large Phillips here. Probably number 2 or number 3. I'm going to turn this one. So I'm doing the black wire here, and as I turn it, I'm getting probably maybe an 1/8 of a turn on that, which isn't too bad. On the other side, I got a good 1/4 turn. Well, it's not super significant, nothing I'd be overly concerned about. And then the other thing is you can kind of look at the wire, and they just ran the wires just straight in here. Now this is all from the manufacturer, so they haven't done anything fancy, and it's a good enough connection. So there's a couple more wires here we can tighten up on the bottom there. I'm going to do those. That one's really tight. That one's same about just maybe an 1/8. And then there's a couple more. You see I just flip that down on top here. So there's one here, another one, and all that. Tighten that up. And so they're not significant. Someone's either gone through this. This is an old water heater. I was trying to look at the nameplate to find out exactly how old it is, but I haven't been able to determine that yet. Not real familiar with the Bradford White and what their model serial number, how they designate the year on them. So anyways, that looks pretty good. As far as anything that you could do on this, you know, if anything were to go bad with the element, you could replace it, and the same with the thermostat if you ever had something where you needed to adjust it up or down. So that's where you do that. So that looks good, and that's pretty much that on that one. I'm gonna go ahead and close this up. Now the other thing I was noticing here, and it's not that bad, is there's a little bit of corrosion around that nut where it mounts in. I've known, you know, guys that are plumbers with their own stuff. I've never had a real need for it, but where they'll come in and actually put on a you know, like a rust breaker or something to kind of keep that lubed up so it doesn't, so when they have to change it in the future, that there's no it's not super hard to pull it off. So the last one we got is the one at the bottom here. And this is generally the element that will fail first, surprisingly. Even though the top one is generally, the The bottom one's generally the one that fails the most due to the fact that it's generally coming on more often as the cold water enters. It's coming on more often, and then it's also where the sediment, if you're not draining this, the sediment would fill up, and then as that encrusts the element, the element will fail because it's heating up, but it can't dissipate that heat, and eventually the heating element explodes and shorts out. So they got a ground wire here kind of coming to the case. I'll kind of pull that off a little bit, and we got the same thing down below. Now on this one, the top element was set for 130 degrees, and then this bottom one's actually set for 120. So generally they're at the same. So it's kind of interesting that it's set differently. Or you'll see the bottom one at a higher setting. But I'm going to go ahead and tighten up this electrical on this bottom one. Same thing on the element, so we'll see if we get more of a turn. And there's definitely, it's loosened up more on this bottom one than the top one was. But nothing outrageous at all, which is good. So that one's tight, and that's it on that. So that will complete our electrical check on this as far as what you can do. I mean, they're really basic when it comes down to it. There's not a whole lot. So, and like I said, every couple of years is probably more than enough. It's definitely been, unless they had somebody that came through here when we bought the house and they actually did a proper maintenance on this and they tightened it up. But based on that, that's really good. At our old place, before I replaced our water heater, we had an old A.O. Smith water heater that was 25 years old, and the first time I went through the electrical on that thing, it was quite frightening how loose it was. So this looked good. So other than the incoming power, you know, it wasn't too bad. So okay, so the other thing I was going to say, if you're lucky enough to have your water heater just in your garage, kind of elevated, you can just run a garden hose out, and that's the most ideal. If this was in a crawl space or somewhere that didn't have just had a dirt floor, I'd just drain it right here. But because they have this rat slab on here, I don't want to have any additional moisture, so I'm just going to do the bucket, and you can see. I'll get some. You want to alternate kind of with a quick on and off to help kind of flush stuff out. And we're on a well here. It does get, we do have a pretty good sediment filter, and I'll just kind of let that sit. And it's dark. It's actually not that bad. I'm pretty happy with that. It's a little dirty, but it looks pretty good. And this one has some sort of reduced sediment buildup. I don't know what they do with how they run the pipes down for the water, but as I got this shut off, I don't have it cranked down a lot. It's dripping now. So like I said, it's probably gonna. Sometimes you can fix it just by really clearing it out, and then this is another bucket here, and I'll do a couple of these. And generally, if I have just a garden hose, I'll just let it flush for a while so it's clear. Now it's getting clear, so it's looking good. So now it looks a lot better. So it wasn't a whole lot in there. It's very likely that when they sold the house, when they went through and did their maintenance, that they had somebody flush this, because if that's been a couple years, I'd be surprised, but that looks really good. So then the other thing we're going to do, I'm going to put the bucket over here again. And this should be done frequently as well. Go up here. And that's on your pressure relief valve, your PRV. Generally they're on the top or off the side somewhere, and they should be piped outside for the overflow. And what this does, if it gets too hot, this will actually release and dump water out, so you don't have a catastrophic explosion. And so with that being said, generally you want to flush this thing, and they'll say it on here a lot of times how often you want to do it. I don't know if this one does or not, but a lot of times in the maintenance manual and these will tell you that you need to do it, you know, every 3 months, every 6 months. Generally, if it's something real accessible, you know, my old water heater that was in the basement next to our washer dryer, I'd blow this off quite frequently, you know, probably, you know, almost once a month, and just helps keep that clear, keeps the seat and the spring and everything in good working order. Sometimes what happens is they sit for so long and they get hot, and that seat kind of almost melts to a point, almost like it does on the bottom with the drain valve, and becomes deformed. So the first time it actually does go off, there's something wrong, and thermostat's starting to act wonky, and it heats up too much and it blows off. A lot of times it won't reseat, and then you'll see a constant stream. And so that's something to be aware of. And I got to be careful here because since this is in a crawl space, you know, I don't see it. I don't know if there's anything here. I actually have a water alarm I'm going to put up here that will set an audible if there's any sort of leakage around here. So I'm going to set that up today. But so all you do on this is just has this little spring kind of actuated valve. I got the bucket set up again just so I can collect the water, but generally you can just blow it off. It should drain outside or into an area that you can collect. I'm just going to pull it up a little bit. You might get a little sediment on this one. There's a little bit there, not a whole lot. I'll just close that, let it seat itself. And then if it starts leaking, sometimes you can hear it or you can feel the pipe. And this one is plastic, so it's not as easy to feel. But you know, if you feel here, it'll be hot. If it's copper, because it's conducting from here. But if you come over here and it's still hot, you know, let's say this goes into a wall or outside somewhere, and you can feel it and it's warm. It shouldn't be that warm, you know, more than a couple inches away from the valve. And you know you have a problem and that the valve's probably leaking, and you can buy a new one and replace it. And it's a good idea if you have a problem with it just to replace it, just so for safety reasons. And other than that, the only other thing I would say, you know, I got the pipes coming in. They're on these, most water heaters now will have, they call heat trap valves in these. And if you did happen to have an old water heater, you can buy new ones. And they're just the nipple, and they have something in it that keeps it from the heat from kind of going out. But, you know, this is my hot water one here. And even though I had running before we did the video with doing some dishes, that it's, you know, it's really not warm at all. It's my cold water in. You should have a shut-off valve accessible. Some people will turn that on and off to kind of keep the seat on it good. I kind of don't like to do it a lot of times unless I know I'm going to be shutting off the water heater for something in particular. Generally I use the main water shut off, and I like to use the ball valve versus this is called like a gate valve. And just because this stem, and you can replace the packing, but it's just a pain, you know. So it's just, if you don't touch it a lot of times, you know, if you don't need to, use your main water shut off, and that way you have one main valve and shuts the water off the entire house. But other than that, that's pretty much all you got to do. And then I'll just kind of, I don't know if I can show you that. Yeah, can't really see it from that angle, but there's a little bit of debris in the water, and kind of see the floaties there. Some of that might have still been, but it's got a little bit of gray, darkness to it. That's pretty much it. That's the maintenance on there. So what you should do is every year at least blow off your pressure relief valve and flush your tank. And ideally, you know, if you can just hook a garden hose up to it, just let it flush for, you know, a couple minutes and really get the water out. And that's always a really good idea. But thanks you guys for watching. If you have any questions, let me know.